Chal in this one. I've opened an older paper. That's summer 15. So in which option do all the particles have the same electronic configuration and the same number of neutrons? Yeah, can you hear me?
Yeah, we can hear you.
I mean, that's an easy one. You have basically the same number of electrons, right?
Yeah.
So what about the first one? Do they have the same number of electrons? I mean, they're all going to have 10 electrons, right?
Yeah.
So they all have 10 electrons, except do they have the same number of neutrons as well? I think this is 8.
No, they don't have the same number of neutrons.
So which one is the answer? What about the next one? It's the electrons are the same.
Yeah, for all of them and neutrons.
So B is the answer for this.
Yeah.
The shell of a chicken egg makes up 5% of the mass of an average egg. An average egg has a mass of 50 grams. Assuming the egg is pure calcium carbonate, right? So we're dealing with calcium carbonate over here. How many complete eggshells would be needed to neutralize 50 cm cube of 2 mole per dm cube? Ethanoic acid. So I need to first come up with an equation, right? And sorry, it's calcium carbonate. So it's going to be plus water plus carbon dioxide. Can you tell me how many moles is this?
This is
2 times 50 divided by 1,000, right?
yeah.
Can you double check this? It's 100 over 1,000, right?
Yeah.
So we've got 0.1 moles of ethanoic acid. So your moles of calcium carbonate would be half of that, right? So it's going to be 0.05 moles, right?
Yep.
And since it's going to be 0.05 moles, you can figure out the mass, which is going to be 0.05. Multiplied by the molar mass of calcium carbonate, which is so it's 40 plus 12 plus 16 times 3. What do we get?
One second. You get 3.2.
You're not going to get 3.2.
Oh wait, I did a mistake. 1 sec. We're gonna get 5.
So you're getting 5 grams, right?
Yeah.
So you need 5 grams of calcium carbonate. So So one egg has how much calcium carbonate? One egg has 5% of 50 grams, right? So that's what's 5% of 50? Is it 2.5 grams?
Yeah.
Right? Because 5% of the mass of an average egg, which is 50 grams, is calcium carbonate. So one egg has 2.5 grams. So we're looking for 5 grams. So we need how many eggs we need?
2 eggs.
So he says the compound can react with, so he says pH3 can react with H plus one ions, right? So what type of interaction do they have?
Wow. Is it what's it called? Dative covalent bond?
You know why? Because your your pH3 molecule has a lone pair, and your H plus one is going to come in, and it's going to form a dative bond with that lone pair. So it's going to be a dative covalent bond, right?
Mm.
So which solid has a simple molecular lattice? Who's out of these four? Tell me the structure of each one of them. What's calcium fluoride?
Calcium fluoride is a tetrahedral.
They need the structure. Is it a giant ionic lattice? Is it a metallic lattice? Is it a giant covalent structure? Is it a simple molecular structure? I mean, there are four structures,
Giant.
right?
It's a giant covalent structure.
So this is ionic. It's a metal and a non-metal.
Yeah.
Calcium is +2 and fluorine is a non-metal. It's -1. So it's. What about nickel? What kind of structure would nickel have?
Nickel would be a giant metallic structure. Metallic lattice.
So it's a giant metallic lattice, right?
Yeah.
What about silicon 4 oxide?
Giant covalent structure.
Okay, that one is covalent structure or covalent lattice, right? What is sulfur? And what's
Sulfur
the
is a
formula of sulfur? Sulfur has a
S2.
no, it's S8 actually.
Um,
You get it. Remember in organic chemistry, sulfur is a lot of van der Waals for. It's
yes.
a it's a simple molecular, right?
Yeah.
And so you got PV equal nRT. So he says, what is the mass of methane given to two significant figures? Assume that the gas behaves. So he's given a bunch of information. So remember, you have to get the units right. The pressure has to be in pascals, so it's going to be 103. The volume is given in meter cube, which should be in meter cube. So it's N is the moles. So, and we know it's methane, right? So moles is mass divided by the molar mass, which for methane is 16. R is given to you 8.31, and the temperature has to be in Kelvins, right? So that's what's 273? That's 333, I think.
Yep.
So find the mass now. and tell me the answer.
The answer is D.
What's the answer?
D, 3.2 grams.
It's 3.2. I said next one is this. How do you find the enthalpy based on enthalpy of combustion?
Oh, um, you find it by the heat energy that is the heat energy
Sorry,
given.
tell me what's the answer? Yeah, how do you find it?
It's when the heat energy given out is one. The heat energy given out when 1 mole of a substance burns completely in the presence of oxygen.
In excess oxygen.
Yeah,
Energy leaves when okay, so how would you calculate what are the two formulas for finding the enthalpy using Hess cycle? One is
Oh,
based on enthalpy of combustion, the other one is based on enthalpy of formation.
the Hess's law will tell us the like H1, the first path and the second path.
I tell you, sorry, he's actually asking for which expression will give a correct value for the enthalpy change of formation of. So it's not the above equation; it's a different equation. Okay, the metaldehyde has to be formed, right?
Yeah.
So it's CH3CHO 4 times, and it's going to be formed from its elements, which are what? Carbon, hydrogen, and oxygen, right? So the carbon, there are two carbons, and there are two hydrogens, and there's half oxygen, right? Actually, that's 4 times. So it's actually 8 carbons and 4, 4, 16, 8 hydrogens and two oxygen gas molecules, right? अच्छा अब बताओ okay, how would you calculate the enthalpy change of? He's asking for the enthalpy change of this reaction.
Is it gonna be C or D? It's C.
C, it's the enthalpy of combustion of the. I mean, what are the formulas? The two formulas, right? One is based on enthalpy of combustion, which is enthalpy of combustion of the reactants minus the enthalpy of combustion of. So C is this C? I think it is C, right?
Yeah, I think so too.
Okay, so copper metal is purified by electrolysis, which change to the mass of the electrolysis is not in your course. Um, so N2O4, you want the greatest yield of N2O4. So what is going to push the equilibrium to the right?
Will it be high pressure and low temperature?
High pressure and
Low temperature.
low temperature, yes, because it's an exothermic reaction, and high pressure and low temperature, yes. So there's this you have to calculate Kp, right? And he says that there's a sample of HI which is warmed and an equilibrium is established. It is found that the partial pressure of HI is 28 times the partial pressure of H2, right? So if the partial pressure of H2, I take it as X, right? The partial pressure of I2 would also be X because both of them will be produced in equal amount, right? Is that clear? So they're going to have the same mole fraction. Is this clear?
Yes.
And HI is 28 times larger, right? So it's going to be the partial pressure of HI would be 28x. So we can just write the Kp expression, which is product pressure. So that's x into x, that's squared, divided by the reactant pressure, which is 28x, and that's also going to be squared because it's 2HI. So the x square will get cancelled out. So basically, you are left with what? 1 over 28 squared. What do we get?
Yes. 1/784. So
Kya B?
D 784.
It's going to be a very small value. It's 1 over 28 squared.
It's D, Mr. Fahad. 784 because it was 1/784.
So 1 over 784 is not 784.
Oh, okay. So which
Nikya, is it A or B?
B?
Okay, so it's B.
Okay.
So photochromic glass used for sunglasses darkens when exposed to bright light and becomes more transparent again when the light is less bright. The darkness of the glass is related to the concentration of silver atoms, right? The following reactions are involved. Now, which statement of these reactions is correct? So, I mean, it's this one, it's A.
Okay.
I think because the copper plus one are acting as a catalyst because they kind of remain unchanged, right? Is that clear?
Yeah. Yes.
So then you've got the Boltzmann distribution below shows the distribution of molecular energies in a sample of a gas at a given temperature. Which statement correctly describes the change in such a distribution if the temperature is increased? So it says when the temperature is increased, right? So your curve, it shifts to the right,
Ah,
right? That's what's happening.
yeah.
Here, this is what's happening.
Mm.
Now, so now the thing is, which statement clearly describes the change in such a distribution if the temperature is increased? So fewer molecules possess the most probable energy value, and this value shifts to the left.
It's B. It's B.
Yeah, this is the most probable energy, right?
Yeah.
I mean, this energy because you got the most particles, right? Previously, this was the most probable energy, right?
Yep.
So you do have fewer molecules possessing the most probable energy value, and this value shifts to the right. So that's correct. So there's a nitrate that's decomposing, a group 2 nitrate. So it decomposes in this way that it's XNO3 twice. And it becomes a metal oxide plus. So this is 3 grams.
Mhm.
And 1.53 grams of gas. So what is left? This is 1.47 grams then, right? Because 1.53 grams of gas is released. ठीक है ये clear है?
Yes.
Okay, so now what you're looking for is that you need to find what X is. The way you can find this is that both of these will have the same moles, right? It's 1:1. So this is the moles of this would be 3 divided by, you don't know what X is. NO3 twice is 124. And the moles of XO are basically mass divided by molar mass. It's 1.47 divided by the molar mass. So it's X plus 16. So you need to solve this now because both of these moles are going to be exactly the same. So if you equate them, that's going to be 3x plus 48 is equal to 1.47x plus 124 times 1.47. You get all the x on one side, so that's going to be 1.53x then. And you take the 48 to the other side, so that's 124 times 1.47 minus 48. And the 1.53 will get, you're going to divide it.
Uh-huh.
So what are we getting?
We're gonna do something. We're gonna get 87.76 or 1,492 over 17.
87. So who's 87? That's strontium.
Yeah, I think that is strontium.
Okay, so I think it is strontium. I said, what happens when a piece of magnesium ribbon is added to cold water? So magnesium is not very reactive. Remember, reactivity increases down group 2, right?
Yeah.
Okay, so it increases down group 2. Magnesium is not very reactive, so it's going to be B, right?
Yeah.
It's definitely not going to float. Uh, Definitely no fast, vigorous reaction, right? Now he says that it releases carbon dioxide.
Yes.
I think it's going to be this one. It's the refractory kiln lining is magnesium oxide because once it decomposes, it releases carbon dioxide.
Mm-hmm.
Okay, so it releases carbon dioxide in a white solid that's magnesium oxide, which is not very soluble. They're both not very soluble. And this is, I mean, this was the, I mean, basically refractory lining. That's magnesium oxide. Okay. So, okay. Let's continue tomorrow then. Okay.
Okay. Thank you.
Okay. Take care.
Wait,
Sounds
what
good.
time are we having class tomorrow?
I'm gonna share a timetable with you. TK, we're gonna start daily classes now.
Okay.
TK till the exams.
Yes,
I
thank
mean
you so much.
you can TK to we can 7th April, right? Yeah.
Yeah.
Tell me what's a suitable time? I'm probably gonna start this do this every day at 6.
6 your time?
Yeah.
Yeah, that's all right with us.
TK. So TK.
Okay, thank you.
Okay. Take care. Bye.